We're almost done. Yeah, let's have a big cheer. Just raise your arms and yes. Okay, good. All right. I got to keep the blood flowing. I know it's late in the day, and you've been great. We're going to cover one more program today, and this is focusing on the Toxic Substances Control Act, or Tsca as it's known for short. And there are a couple of different aspects of it that we're going to focus in on today. In particular, we're going to talk about PCBs and pre-manufacture notice, which are the two areas that the EPA really wants us to zero in on. So, what are we talking about here? This was a statute that was implemented in 1976 to focus in on industrial chemicals that were either produced or imported into the United States. And there were various requirements for reporting and testing on it because of the particular environmental or health risks that certain chemicals may pose. There are a whole bunch of different requirements that are covered under it. We've talked about some already involving lead paint and asbestos. And today what we're really going to focus in on this afternoon has to do with polychlorinated biphenyls, or PCBs as they're known for short, which is the aspect of the rest of the regulations that is going to be most applicable to some of the campuses. So as a quick test, does anybody know if you have PCBs on your campus? Okay. Does anybody know what form they're in or what kinds of equipment they're in? Ballasts, switches, transformers, elevators. Yes. All right, so we're going to talk about all that a bit. Is there anybody who has a campus that does not have any PCBs on it as far as you know? Okay. If your campus is new, then there's a decent chance that that's going to be true. But for any campus that has older buildings, has older equipment, there's a very decent chance that you've got to make sure you may very well have PCBs. So it's definitely going to be an issue to think about. Before we talk about PCBs, there are two aspects of the regulations we're going to go through very quickly. They're not going to be generally applicable to most campuses, but because we're supposed to cover them as part of the EPA agreement, I just want to flag them to you. One is to do a chemical inventory, and that's a general requirement in the regulations. However, there is an exemption for small quantities of chemicals that are used for scientific research or analysis, which is generally what you will find on a college campus. The presumption is that if you have less than 1,000 pounds, that you are using it for research purposes. And so the general presumption is for the kinds of chemicals that this part of the regulations is talking about, your campuses are not going to have to deal with this. If you think you will, then we can talk about it further, but the general presumption is that this is not going to apply. The other aspect of the regulations that we want to cover very briefly has to do with what's called pre-manufacture notice. And this is when a company is going to produce a new chemical substance for commercial purposes. Under those circumstances, the company is required to submit a notice to the EPA. However, like with the previous slide, there is a specific exemption that talks about a chemical substance that's manufactured solely for non-commercial research and development purposes. So again, on your typical college campus, any new chemical that's likely to be produced is going to be for research and development, for non-commercial research and development. The issue that you do have to think about is that if a researcher, a faculty member, has developed a new substance, a new chemical, and they ultimately are going to commercially produce it, then this is subject to the regulations. So if it's only for research purposes, then we don't have to worry about this at all. But if they ultimately intend to market it, to on the side form a corporation or a company and market it, then this is an issue that we have to think about. So generally, for most of the campuses, this is not going to be an issue. But just know that if it is for commercial purposes, that's what you want to ask about. So it's the end result that matters in this case. So with that, that's what we're going to set those two aside, and we're going to focus the rest of the time on PCBs, polychlorinated biphenyls. And the concern here is that they can cause cancer. They can cause harm to us and to the environment. And because they are so chemically stable, they don't tend to break down. So they tend to bioaccumulate. And that's part of the concern. That's why the EPA regulates this. That's why we're going to spend some time talking about it. So as we all said, there are a variety of different places where these might show up on a college campus. So we're going to think about transformers, light ballasts, capacitors, circuit breakers, hydraulic lifts and hydraulic elevators. Okay? So those are the areas that we're going to be thinking about and talking about for a little bit together. What you want to know, and the first very important thing to be thinking about whenever you're thinking about PCBs, is that the quantity of the PCBs, the concentration, is what really matters. And the regulations break down 3 different levels for transformers and capacitors. The key point first is that we're always going to be thinking about 50 parts per million. That's the magic number. If you are below 50 parts per million, even if you have some PCBs, if you have below 50 parts per million, then you're considered to have no PCBs in effect. That's the threshold level. If you're below that, then you don't have to worry. Any of the equipment at all drops off the radar screen. It's not going to be regulated. It's not anything you have to be concerned with. However, if you're above, if you're 50 parts or above, then you do have to think about it. And there are 2 categories that we're going to be thinking about. One is if you're between 50 and 499, then you are considered to be what's called PCB contaminated. And you have to pay attention to those equipment, those transformers. The most important one is if you have PCBs that are at above 500 or above. And in that case, the regulations impose a considerable amount of scrutiny and requirements. So those are the key levels to be always thinking about in terms of everything we're going to be talking about for the next little bit together. If you're below 50, don't worry about it. If you're between 50 and 499, you've got to be concerned and take certain actions. If you're at 500 or above, then you definitely have to make sure you're in compliance with the different requirements. For purposes of SPCC and most regulations, if the utility owns it, then that's true. For SPCC purposes, you don't have to worry about it. However, for this regulation, you definitely do have to worry about it. Because it's on your property. The assumption is that you are going to be able to have access to that, or at least be aware of it, if it should leak, much more quickly than the utility is. So unfair, perhaps, but the fact is if it is on your property, whether it's not, it's owned by you, the campus, you have some responsibility for inspecting it, being aware of it, taking action to address it if it's leaking. Anytime it's less than 50 parts per million, we don't worry about it. The fact that it's a transformer is not important in the sense of what the regulations call for. They're only concerned with transformers that are above 50 parts per million, and in particular, transformers that are above 500 parts per million. If you have a transformer or a capacitor or a light ballast, and it's less than 50 parts per million PCBs, you don't have to worry about the regulations at all. It's not a risk. It doesn't pose an issue. There's no requirement to do anything. It's only when you're above those thresholds that you have to start thinking about it. Okay? So again, the key point is you want to always be thinking about it when you've got 50 parts per million or greater. And one key point here is that if you have waste, if you've got a spill, a release, if the original source, the original transformer in this case, had a concentration that was at 50 parts per million or higher, even if the spill ends up being diluted, the original source is 50 parts or more, then you have to consider it as being subject to the PCB regulations. Okay, so again, you cannot dilute it. That's the point of this. You can't do an end run either deliberately or inadvertently and benefit from that. If it gets diluted, it doesn't matter. You have to go and look at the original source, and then based on that, determine whether you're subject to the regulations or not. Okay? There are different ways in which you can determine the concentration. You can test it. There may be a mark from the manufacturer. There may be some service records. The key thing is that there are some assumptions that the regulations require you to make. If you don't have a mark on it that says no PCBs, then if you have a date on there, that date becomes very important. The key threshold date is July 1979. Earlier than that, then you have to presume that the equipment, the transformer, had 500 parts per million PCBs.
From 79 down.
Down, earlier. So from 79, 78, 77, going earlier in time. From July 1979, going earlier in time. If you don't know anything more about it, you have to presume that it has 500 parts per million PCBs, which puts it into the highest regulated category. If it is from closer to us, more recently than July 1979, then you can presume that it was less than 50 parts per million, because that was the key date at which point it was no longer legal to manufacture anything in the United States that had PCBs above 50 parts per million. So if you've got a transformer, if you've got a capacitor, if you've got a light ballast, if there is a date on it that you can tell when it was manufactured, that's the key date to be looking for. If it was manufactured in 1985, you're safe. If it was manufactured in 1975, then you've got to presume that it was. And again, this is a rebuttable presumption in the sense that you can still test it and see. But if you don't have any other information, if all you know is the date, you must make this assumption. This is what the regulations require you to do. All right, any questions about that?
I could add something. I had a client recently who evaluated all of their transformers and things on campus, and using the manufacturer name and serial models of the transformers, they were able to make a lot of this determination just based upon that information. They could look up and find out whether these originally contained any PCB oil. So if you don't know, that might be one avenue to try to investigate.
Right, right. So it's a very important point. Just because this is what the regulations require you to presume, it doesn't mean that every piece of equipment has that level. But if you don't know anything more, that's the assumption you have to make. All right? So I want to make sure everybody's got a clear understanding of that. We're going to talk about different types of locations on campus or types of situations where you might encounter PCBs. One of them has to do with hydraulic systems, elevators, trash compactors, anything that may have hydraulic fluid in it. The key date here is July 1st, 1984, because after that date, PCBs were only allowed in concentrations below 50 parts per million. So we're shifting over for a moment from talking about transformers and capacitors, which you talked about a minute ago, to talking about hydraulic systems at the moment. Now, this is a firm date that you are supposed to be able to rely on, and this is what the regulations allow you to presume, and you can rely on that.
Why did they allow field vacuum hydraulic systems that less than 50 ppm?
I'm sorry?
Why did they allow the PCBs to be put back in hydraulic systems that was less than 50 parts per million?
It's because the risk analysis that the regulators did said that if it's below 50 parts per million, it's not a risk to the environment, it's not a risk to human health.
Well, is there some characteristic that caused it to be allowed to be added back in here that made stuff operate better?
It's not that you would want to add it back in. It's that manufacturers of hydraulic oil, to the extent they wanted to put any PCB in the hydraulic fluid, years ago that you could put in as much as you wanted because it was beneficial to some of the qualities that you wanted in the oil. Starting in July of 1984, you could only put in less than 50 parts per million as you manufactured it. From that point forward, when you manufactured hydraulic oil and you started servicing this equipment, you could not sell or use in the United States hydraulic oil that had 50 parts per million or more. It has certain beneficial qualities, just like asbestos does. That's why people originally used it. But at some point, the risk and the danger to using it outweighed the benefits that it provided to the equipment. And so it was banned at 50 parts per million and greater.
So it wasn't banned in elevators at the same time as it was in transformers?
Right. It was not banned in elevators at the same time. So there are two different dates that you want to be thinking about depending on the type of equipment you're dealing with. Transformers and capacitors, July 1979. Hydraulic systems, elevators mostly, trash compactors, it's July 1984. Okay? What you want to know here is that there is no mandated testing of pre-1984 systems. So you can have an elevator that goes back to the 1970s or the 1960s. There's no requirement to test that. However, if you have a leak or you have to deal with the hydraulic fluid, if you don't know anything more about it, you have to presume that it has above 50 parts per million, and you have to treat it as if it's PCB waste and handle it accordingly. So as a good management practice, you may want to have it tested, especially if you think you may need to have work done on it at some point, to know what you're dealing with. Because what you don't want is to have a leak at some point or a spill and have an emergency, and then in the absence of knowing anything more about it, you have to presume that it's going to be a PCB waste. In that case, if there's a record of that, that allows you to move over and presume that it was safe, that the hydraulic fluid that's currently in there is below 50 parts per million, because at that point you have a hydraulic system that was put in place in effect after 1984.
Is there any regulation making you replace it?
No. No, that's the key thing that I want to make sure everybody understands. There is no obligation to test it. There's no obligation to replace it. However, if you do need to deal with it, if in the absence of any other information, you have to make the assumption that it is contaminated and that you have to treat it as PCB waste if you have to service it. But there's no obligation to replace it. You can continue to use it. All right, any questions about that? Okay. So now we're going to shift over for a moment and talk about transformers. And here, when we talk about PCB transformers, I want everyone to keep remembering, we're talking about here, this is a specific term that the regulations talk about. A PCB transformer means 500 parts per million or greater. If you go back a couple of slides, whenever you talk about straight PCBs, we're talking about 500 parts per million. If something is PCB contaminated, then we're talking about between 50 and 499 parts per million. So again, this is a term of art that the regulations refer to, and it's a distinction between different categories of items. So in this presentation, as we talk about PCB transformers or later PCB capacitors, we're talking about those pieces of equipment that have 500 parts per million contamination. All right? Does anybody know if their campus has a PCB transformer, meaning a transformer that has 500 parts per million or more?
500, I don't know, but
Yeah.
no, it does have PCBs.
Okay, so the key thing here is, does it have 500 parts per million or more?
We did at one time.
I know Georgia Tech does, yes. The key thing, one of the key things you need to know is that if the campus has PCB transformers, they all had to be registered with the EPA as of 1998. All right? So the key thing to know, if you have, and again, I'm talking about a PCB transformer, which means a transformer that has 500 parts per million or more concentration of PCBs. Each of those had to have been registered with the EPA by 1998. The reason that if you take possession after 1998, you were allowed to presume that the prior owner registered them. It's obviously good to get a copy of that documentation, but if your campus has PCB transformers with concentrations above 500 parts per million, you want to make sure that they have been registered with the EPA. Okay? You are not allowed to store any combustible material either within the enclosure or within 5 meters of a PCB transformer. All right, so just know that. It's unlikely to happen, but just make sure that that's how you're handling the area immediately around any PCB transformer. Okay. If you have, again, a PCB transformer, 500 parts per million or more, you have to do an inspection every 3 months to check for leaks. There's one exception to that. You can do it once a year as long as the transformer has secondary containment and it contains less than 60 parts per million PCBs. 60,000, I'm sorry. 60,000 parts per million. 60,000 parts, I'm sorry. I shouldn't say parts per million. You do want to keep these records for at least 3 years. All right? Make sure you keep the inspection records for at least 3 years. Yes.
And the one that
Yes.
utility owns on our property, I guess I should get the records from them for inspections for the last 3 years, since I know we haven't been doing it. They're supposed to have been doing it.
Well, arguably they should do it, but I think also you should be doing it because it's on your property.
But for the last 3 years, should we get records from them? So
Yes.
we can get copies?
Yes. But you should also consider that as a responsibility of the campus as well going forward.
We
Unica?
also ensure that they had an SPCC plan and that they had environmental insurance.
That's a good question. Are there any other requirements that you'd, or requests that you would make of the utility company when you've got one of their transformers on your campus and the suggestion, the recommendation is to make sure they've got an SPCC plan that covers the transformer and that they've got appropriate insurance in the event that there should be a leak or any kind of environmental damage?
Well, we found that Georgia Power does not, right? For the transformer station? And Mary, there are probably more transformers on your campus that are just apparently visible. We find them, or I find them, you know.
Everywhere?
Everywhere.
Yeah.
I'd come up on them and say, I forgot about this, and then we'd call in because she puts a label on it. She's a label person.
Good. All right. Well, that's actually a very good segue into the question, what do you do if you should have an incident with a PCB transformer? Again, a transformer above 500 parts per million or more. You need to clean it up as soon as possible and certainly within 48 hours of discovery. So you want to take action immediately. If there is any kind of fire-related incident, then you have to immediately report that to the National Response Center and take any appropriate measures to prevent the release of the PCBs into any water. Okay? So again, make sure it's unlikely to happen, but if it does, make sure that you take action immediately. This is not one that you can wait on at all. Any questions about PCB transformers? PCB capacitors, another kind of equipment that also often can have PCB in there, and it's the same issue. We're talking about the same 3 grades of concentrations, and in this case we're talking about PCB capacitors with 500 parts per million or more of PCBs.
These are usually, you don't know that they're there.
Right,
They're buried in vaults
yes.
under
These,
the ground, and you're not going to find them until you dig them up.
yeah. The comment was these are often hard to know that they're there, and that's true. In many campuses, you may not always know what's there.
EPA won't know either.
But if you haven't, talked to anybody in the facility staff who's got good historical knowledge about electrical systems, electrical equipment, who might know where these might be located.
The way you find them is when you've done all the stuff for the ESA to build a new building, and you start digging up stuff that's been covered up by the Army over years, and these things fall out of the vault. You go, what's this? That's when you find out that contingency money for in the project, you'll use some of that 10% at the front of the job.
Is it in the regs that I've got to say, what's this? Oh.
Due diligence,
Okay. Yes, Andy. It's the same date as transformers. Consider transformers and capacitors to be subject to the same general set of requirements. So we're talking July 1979 for capacitors as well as for transformers. Okay, so now we've talked a little bit about different types of equipment. What do? Well, you have to mark certain equipment. You have to mark every PCB transformer. Again, PCB transformer means 500 parts per million or more. Okay? You also have to mark if there's a means of access to the door or the fence to the transformer. If there is a perimeter or a gate around it of some kind, you have to mark that as well. And that's why this is absolutely required. Before, when I talked about the best management practice, it's good to mark all the other transformers so that you know that this doesn't apply to them. So if you have changed out the oil, what used to be a PCB transformer now no longer is because the oil has all been changed out, mark it as non-PCB so that you now know and everybody else knows that you no longer have to worry about this requirement.
It looks like a standardized label.
Yes, this is a standard label. This is,
You get it from here.
you can get it from any label supplier.
So there's more than 50 up to 499. What do you mark?
You don't, there's no requirement to mark that, but it's a good idea to. So what you would mark that as PCB contaminated.
Not that label.
Not this label. This label is only for 500 parts per million or more. Okay, this is exclusively for 500 parts per million or more. So don't mark anything that's less than that, but make up a label that says PCB contaminated. The reason that they don't generally exist is because there's no regulatory requirement to mark them that way. But come up with something so that everybody knows, if you've had that tested, what the current level is there. And certainly if you've had that tested or replaced and it's below 50, absolutely label it so that everybody knows what the conditions are there. Okay, any questions about that? Okay. Right. Just like with transformers, you need to label PCB capacitors, all right? Or any equipment that contains either a PCB transformer or a capacitor. All right? We're also going to talk in a minute about waste storage areas. So you need to make sure that those are labeled too if you're storing PCB transformers or PCB capacitors in those storage areas. All right? And these two terms at the bottom, I'll explain very quickly. A PCB container simply means every PCB item, if you put it in a container and the container touches the PCB oil, if it leaks into the container, the drum or the encasement, then that becomes a PCB container. A PCB article container is a way of distinguishing it. It's a funny term of art in the regulations. It simply means if you have, for example, light ballasts, and they're not leaking. You put them all in a drum. The drum itself never comes into contact with the PCBs. That's considered to be an article container because it's not actually come into contact with the PCBs. That's just the way the regulations distinguish between different situations. So just,
If I drop a ballast in storage drum, with
This article.
it becomes, the drum itself becomes an article container as long as the drum itself has not come into contact with the PCBs. The drum itself is not contaminated, it's just the vehicle that's holding the ballasts,
even on the inside,
even on the inside, as long as they're not leaking. So, if you have PCB transformers or capacitors, PCB contaminated transformers or capacitors, light ballasts that are above 50 parts per million, anything at all that's above 50 parts per million, if you take them out of service, if you want to dispose of them, you can dispose of them within 30 days and you don't have to worry about the requirements that I'm going to talk about now. If you hold them on your campus for more than 30 days, then what you have to do is create a PCB storage facility. If you hold it for less than 30 days, then you can just hold them there temporarily and ship them off. You don't have to worry about what I'm about to talk about. But if you hold them for more than 30 days, then you have to create a PCB storage facility. And what that is it's essentially a requirement to create a safe place where, in the event of a leak, you're going to make sure that everything is contained properly. So the requirements of a storage area are that you have a 6-inch berm that's going to create a containment area. That containment area is at least big enough to hold the amount of PCB fluid that might leak out. It's got to be twice as much as the single largest PCB item that's in there, or a quarter of the total volume of all the PCB items that might be stored there. You basically need to have enough containment to make sure that nothing's going to migrate. You need to make sure that the floor is smooth, preferably made of concrete, but some other non-porous material. You need to make sure that it's protected from the rain. So preferably you need to have walls and a roof, but you need to make sure that it's protected from the rain so that, again, nothing can migrate in the event of a leak of any kind. The regulators vary on this a little bit. This is what I'm telling you right now is the strict literal interpretation that the regulations set out. Many regulators will hold you to those exact requirements. I called Region 4, and they said, generally, you know what, if you put it in a 55-gallon drum and the drum is closed, water's not going to come into contact with it, it's not leaking, don't worry about the berm, don't worry about the walls. We're really talking about a large facility that's storing significant amounts of PCBs. But I want you to know what the requirements are in case somebody has a very strict interpretation of the regulations. All right, so if your campus is generally going to be dealing with light ballasts, and you put them in a drum, and you're not dealing with transformers, then the gentleman I spoke to from Region 4 may be correct that in Region 4, well, that's all you need is a drum that's closed. But to be safe, to be conservative, this is what the regulations do require. If you're going to hold it for more than 30 days, make sure that it's got a berm, make sure that it's got walls and a roof, make sure that it's on a flat, impermeable, non-porous surface. If the drum itself is the storage facility, then you put it on the drum. If you have several drums, or you have the drums on the transformer, and they're all within this enclosed space, then you've got to mark the space itself, the larger space. This example is assuming that you have light ballasts, and that's all many campuses are going to have, and you put them in a drum. To many regulators, the drum itself can become the facility. That's the means of making sure that nothing is going to come into contact with the environment. And so the drum becomes the protective wall, and that's the facility. But if you've got more than that, then you've got to mark whatever it is that's the barrier that makes sure that if there was a leak, nothing would leak out to the outside. Okay? So you want to make sure that you've got that set up properly. The other thing you want to make sure, if you are going to be storing anything for more than 30 days, you need to make sure that you have notified the EPA using a designated form, which is called this Notification of PCB Activity. Does anybody know if your campus has filed one of these forms with the EPA? Does any campus store PCB items of any kind for 30 days or more? Okay, well then, at least per regulation, you must file this with the EPA. Again, when I spoke to the gentleman from Region 4, he said, don't worry about this. But this is what the regulations call for. So let me pass these out to everybody, and we've got a copy electronically that's available. All right, on to the next exciting, fun requirement that you may have to meet. If you store or use at least 45 kilograms, which is 100 pounds of PCBs in PCB containers, or one or more PCB transformer, which means one or more transformer that's 500 parts per million, or 50 or more high or low voltage capacitors, you have to maintain an annual document log, which you have to compile by July 1st for the previous calendar year. All right? And there's a specific set of information that is set out in the regulations that you need to have in this document log. You want to keep records of the manifest shipments that you've sent out for PCBs. You need to document each of the items that you sent out, or the types of items, if it's collectible, lots of light ballasts together. You also want to document the total amount that you sent out. So there are a number of things that are set out in the regulations. But again, if you meet this threshold, then you want to keep this log. This is nothing you have to send to the EPA, but if they come and inspect, or your auditors come and inspect, if you meet that threshold, then you want to be able to produce this document for them. And again, when I spoke to Region 4, they said this is really written with industry in mind. So they might not, at least the inspector I spoke to said he would not look for this on a college campus. However, this is what the regulations call for, and when I spoke to EPA inspectors in 2 other regions, they said yes, that they would look for this. So I'm flagging it to you to say this is officially what you do need to have. And so be aware that this is officially the requirement. And you have to keep the log for at least 3 years. Okay? So you're going to ship off your waste. We've finally gotten from the storage area, and now you're moving it off campus. There's a very key distinction between PCB waste and hazardous waste. Hazardous waste, for a small quantity generator, has to leave your campus within 180 days. For a large quantity generator, it has to leave your campus within 90 days. For PCB waste, it must be disposed of within a year. Doesn't mean it has to leave your campus within a year. It means it has to be treated and destroyed within a year, which means that it has to leave your campus something in advance of a year. The typical threshold may be 9 months. All right? So you want to make sure that you are sending it out of your campus with enough time that it is actually destroyed, it's disposed of within a year of being taken out of service. Okay? There is a provision to get an extension, but generally the expectation is that you will make arrangements to have it removed from your campus with enough time to make sure that it is truly destroyed, treated, disposed of within a year. So that's a very key distinction between this particular regulation and the more general hazardous waste regulations that we talked about yesterday. All right? Any questions about that key distinction?
You have to get the paperwork back before a year.
We're going to get to the paperwork, yes. If you hold that thought for just a minute, yes. The paperwork, we're going to get to that because there's a very similar concept to what the hazardous waste regulations call for. All right? So you want to make sure, in order to show that you've disposed of it within a year, you have to mark it with a removal from service date, which is when it becomes a waste.
So when you take it out of a lot, a ballast out of a lot fixture, you write the date.
Yes. Okay. Now, again, I'm going to make a distinction between what the Region 4 inspector told me and what the other regional inspectors told me. The Region 4 inspector said he understands that, particularly for a campus, you may have a number of ballasts. It may take you a while to accumulate a drum's worth of ballasts. He said you don't have to mark the drum until you've got a reasonably full drum so that you don't start the clock ticking. That's his interpretation. He's the lead inspector for Region 4 for PCBs. However, other regions take the position that when you take it out of service, when you remove it and it is no longer being used, that's when you mark it as out of service. So when you take it out of the light fixture and you look at it and say, this no longer works, it is a PCB light ballast, and you put it in the drum, when the first ballast goes in the drum, that's when you mark it as out of service. So I'm giving you the official line. I'm also telling you what Region 4 told me, but I have to go by what the official EPA position is in the regulations. Meredith.
Can you mark the drum, or do you have to mark everything?
You can mark the drum. Okay, this is, in this sense, this part of the regulation is just like the universal waste regulations we talked about yesterday. If you've got a box full of fluorescent light bulbs, if you mark the date, the first item goes in the box, or in this case, the first light ballast goes in the drum, that becomes the out-of-service date. And that's good for everything else in there because everything else has been stored there a lesser period of time. So you're comfortable knowing that you could not be storing anything greater than the out-of-service date. That's the key item that you want to be able to prove to the regulators, that you're not holding it longer than the appropriate amount of time. So in that sense, this part of the regulations is just like what we talked about yesterday with the universal waste. You can mark the container as long as you mark it the first time the first item goes in there. Okay? Any questions about Anything we've talked about so far?
Some have to have a lid on.
Yes. Yeah. There's a theme to all these regulations. Yeah. Yes. It does have to have a theme. It's got to be closed unless you're adding to it or taking something out of it. All right? Okay. One other key thing to think about is that, again, we talked about this before, if your PCB waste has a concentration that is, in the end, less than 50 parts per million, but it came from a source that was greater than 50 parts per million, it's got to be managed as if it was at that higher concentration. We touched on this earlier in the presentation. You cannot take advantage of the fact that it may have been diluted, whether deliberately or inadvertently. You have to treat it by what the original source was in the equipment, if something was leaking out of equipment, for example. All right? So, it's now leaving the campus. What do you want to think about? You need to have a hazardous waste manifest for PCB waste. And this is true even if you otherwise are a conditionally exempt small quantity generator of hazardous waste. So again, what we talked about yesterday, generally, if you're conditionally exempt, you don't need a hazardous waste manifest. However, if you're shipping off PCB waste, you do need a manifest. Every shipment of PCB waste must have a manifest with it. It doesn't matter what category of hazardous waste generator you are. Every shipment of PCB waste must have a manifest that goes with it. All right? And you need to indicate the out-of-service date, you need to indicate the weight, you need to have a specific serial number to identify it. There are certain requirements that need to show up on the manifest.
Who doesn't necessarily?
You've got to track your manifests for PCB waste just like you track your manifests for hazardous waste. So what we talked about yesterday, needing to make sure that you get a signed copy returned to you, you have to do the same thing for your PCB waste manifests. And you need to get it within 35 days, or else you have a responsibility to try to contact the disposer and track down the manifest. If you don't get the manifest within 45 days, then you have to file the same kind of exception report with EPA or with EPD. This is the exact same requirement that we talked about yesterday with hazardous waste. The same thing is true for PCB waste. Okay? And again, just like with hazardous waste, you have to keep a copy of the manifest for at least 3 years. And just like with hazardous waste, my recommendation is that you keep it forever so that you can always show and prove where your waste went. Okay? But these regulations are exactly the same for PCB waste as they were for the waste we talked about yesterday, the hazardous waste we talked about yesterday. Question?
Yeah, the first one up there, generator must confirm receipt by the close of business day after the return manifest is received.
Yeah.
What is that?
What the regulations say is you're supposed to call the facility and just confirm that it actually got there. You get the signed copy back. You're supposed to call them and say, you really got this, right? You've signed the receipt, you've sent it back to me, but we want to make sure you really got it. That's not an easy thing to verify, so I'm not sure I would worry about that quite as much, but you do want to make sure that you get the manifest back.
Yeah, because my next question is, does EPA expect us to document the call?
No, I don't think you have to worry about that as much, but I do think you absolutely have to worry about making sure you get the manifest back. Now, there is one other piece of documentation that you're going to want to be thinking about. You have to file a 1-year exception report if you shipped out your waste within 9 months of its removal, which is why earlier when I talked about how long should you hold on to your PCB waste on the campus before shipping it out, you have a year to make sure it's disposed of. Backing up from that, if you ship it out at least within 9 months of taking it out of service, that's a good deadline, because if you've shipped it out within 9 months and within 13 months you haven't received a certificate of disposal, then you have to talk to the EPA. Now, what's a certificate of disposal? This is a new requirement. It's different from hazardous waste. It's new in that sense. It's not a new requirement, but it's different than anything we've talked about so far. In addition to getting your manifest back, because the regulations focus on the actual disposal, the actual destruction of the PCB waste, the destination facility has to send you a certificate of disposal confirming that the PCB shipment you sent actually was treated and destroyed. So you're going to get two pieces of documentation that you've got to track: the manifest and this certificate of disposal. So for every shipment that you send out, you want to get the manifest back within 35 days, and you need to get the certificate of disposal back within 13 months of when it was taken out of service. Otherwise, you have to file an exception report with the EPA or EPD. All right, is everybody clear? You're looking for those two different pieces of documentation. Any questions about what you're looking for or thinking about? Okay. I'm sorry? Only for PCBs. What we're talking about right now is only for PCBs. So I'm distinguishing between what we talked about yesterday, which is generally hazardous waste, and only the very specific category of PCB waste here. Okay. So we've talked about the regulations a little bit. Now we're going to go out and audit. What are we looking for? What are we thinking about as you go out and audit? Well, you want to take a look and understand on the campus what the number of transformers are, if they're elevators, where they are and what they are, if they're hydraulic elevators. If there's been any testing of fluids for PCB content. If there's been that notice of PCB activity that's been filed that we just handed out. If there's an annual document log. The manifest, the certificates of disposal, and the exception reports. If there have been any PCB releases or transformer registrations. These are all the types of records and pieces of information that you'll be asking about and thinking about when you're auditing for PCBs on a campus.